Consuelo, everybody. This is going to be pretty quick. I'm just going to go through what we're going to do on the next video. Really, none of this is new except for one thing, and even that's not completely new. And that one thing is the idea of local maximum or local minimum, and I'll talk about that in a second. Okay, so what I'm going to do is I'm going to give you a polynomial and ask you questions. And I've done this for parabolas, I've done this for lines, so there's nothing new here. Like I say, with the idea of local maximum or local minimum. Okay, so first I'm going to ask you to tell me the domain and range. You should know how to do that. If you don't, go back and study it in chapter 2. Next, local maximum or local minimum. Okay, what do I mean by that? All right, when we had a parabola, let's say, and don't write this down, just listen. You don't have anything to write down in this video, okay? But let's say you had a parabola and the vertex was 7, 9, okay? Did this parabola have a local maximum? I'm sorry, did it have a maximum or minimum? It has a minimum because it has a bottom to it. Okay, what's the minimum? 9. Okay, if the parabola had been opening the other way, it would have a maximum because it has a top to it. And what would the maximum be? 9. Okay, there's nothing new there. Okay, but what's new then? Sometimes you don't have a maximum or minimum to the entire graph, but you can have a maximum or minimum over a small part of the graph. Or you can have a maximum for the entire graph, but also they're like maximums just over a local small area. Okay, what does all this mean? Let me just give you an example of this, okay? Okay, let's say you have this graph. Okay, and again, just listen. Okay, let's say this is the point 4, 9, and this is the point 7, -3. Actually, let's make it 7, +3. Okay. Now, is there a maximum, an absolute maximum or minimum for this graph? No. Why not? Because this graph keeps going up to infinity, so there's no top to it. And this graph keeps going down to -infinity, so there's no bottom to it. So there's no maximum or minimum for the entire graph. But notice here, there's a maximum over a small part of the graph. In other words, there's some sort of top to a part of the graph, okay? And what's that local maximum? And again, it's a maximum because it's the top. It's 9. Here, there's no bottom to this graph, but because it goes down to -infinity, that's the whole graph. But the graph over this small part does have a bottom. There's a bottom to a part of the curve. And what's that minimum? In this case, it's a minimum. It's 3. So there's no maximum, but there's a local maximum of 9. There's no minimum, but there's a local minimum of 3. Okay, let me show you another example here. So I'm going to get rid of this. Okay, what if you have this? Actually, no, I don't want to do that. I'm going to change this a little bit. Okay, let's say this point is, I don't know, 4, 10. This point is 7, 2. And this point is 12, 15. Okay, does this graph have a maximum for the entire graph? Is there a highest y value, a largest y value on this graph? Yes, it is. It's 15. So there is a maximum for this graph, okay? Is there a minimum? No, there's not, because it goes down to -infinity. Okay, well, are there any local maximums? And you can have more than one local maximum. You can only have one maximum, absolute maximum, but you can have more than one local maximum. Yes, there are 2 local maximums. There are 2 tops to a curve, So the local maximums are 10 and 15. Now, there's only one maximum for the entire graph. That's 15. But there are two local maximums. And that would be 10 and 15. Okay? Is there a minimum for this graph? No, because the graph goes all the way down to negative infinity. But is there a local minimum? Yes. And that would be 2, because that's at the bottom of the curve. So it's not really a totally new idea, other than we've never dealt with local maximums or local minimums, but we've dealt with maximums and minimums before. That's not new. Now, I'm not going to go through like every single possible, example that I could give you, because I can't do that. There are an infinite number of examples I could give you. But I just want to say there can be more than one local maximum, more than one local minimum. For instance, let's say you have this. And I'm not going to give the points. I just want to show you something. Okay, is there a maximum to the entire graph? No, because this graph keeps going up to infinity. Is there a minimum for this entire graph? No, because this graph goes down to negative infinity. But are there local maximums? Yes. Actually, there are 3 local maximums. And again, I'm not going to use numbers, but there would be, you'd pick the y-coordinate for that point, and that point. So there would be 3 local maximums here. Would there be any local minimums? Yeah, there'd be 1, 2, 3. Okay, are there always the same number of local maximums and minimums? No, if you go back and look at the one I just talked about before this, there were 2. I can't remember if it was 2 maximums or 2 minimums, but there were 2 of one and only 1 of the other. Okay, just real quickly to kind of like give you just something else. What could it look like? Okay, is there a maximum to this graph? No, because it keeps going up, forever. Is there a minimum? Yes. Minimum for the entire graph would be the y-coordinate of that point, because that's the lowest point on the entire graph. Okay, that's a minimum period. Okay, now it's also a local minimum, but it's also the minimum for the entire graph. Okay, how about local maximums? Well, yeah, even though there's no maximum for the entire graph, there's a local maximum there, there, and there. So there are 3 local maximums. How about local minimums? Yeah, there's 1 there, 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 and there. And again, all you'd be telling me is the y-coordinate for each of those points. Okay? So that's really about the only thing that's new. Interval of domain over which the range is increasing, interval of domain in which the range is decreasing, interval of domain in which the range is constant. That goes back, we've been doing that since chapter 2. Degree of the polynomial, I've discussed that before, and behavior, whether it goes up or down. So none of this is particularly new. Even this idea of local maximum or local minimum, even though we haven't done that before, the idea of a maximum or minimum we've done, but not just a local maximum, okay? And remember, the end behavior, the right side tells you what the leading coefficient is, whether it's positive or negative. The left side, as compared to the right side, not just the left side by itself, but as compared to the right side, tells you whether there's an even degree or an odd degree. Okay, it's just a matter of now taking a look at an example, which we'll do in the next video, but I just wanted to, first of all, discuss that idea of local maximum and local minimum. Have a good day, everybody.